Okay, guys, I'm gonna do the review-ish, okay? I'm not gonna do the whole thing, okay? And I'm gonna do it just kind of making sure that I cover all the topics that are gonna be on your quiz for this section. So the quiz covers 4.1 to 4.5. And I'm just gonna make sure I hit all those topics, okay? If you're in my class, I went over with you in class all the stuff you need to know. Vertical asymptotes, horizontal asymptotes, oblique asymptotes. What else? Sketching a graph. The distance and time equation, all that kind of stuff, okay? So I'm going to kind of just make sure that I cover those topics with these problems, okay? So in task A, let's go ahead and look at this problem that they're giving. They're giving us a situation about a swim club with a 100-meter freestyle race. That means that we have a distance of 100 meters. They want me to write a function, f of x, that represents the time. That means that f of x is time. And it's for the 100-meter race, and x is the speed. So the way that it works is that time equals distance divided by speed. So now knowing that, time, which we said f of x was time, equals distance, which is 100, divided by speed, which in our case, it was x. X is the speed. So this is the function, you guys, all right? What's the value of f of 2? Inside the parentheses is x. That just means plug in 2 for x. So plug 2 in right there for x. 100 divided by 2 is 50. F of 2 is 100 divided by 2, which is 50, okay? What does it tell you about the race? That tells you that with a speed of 2, meters per second, it takes 50 seconds to finish race. Which matches. So you guys can see all the shapes are about the same, other than this one, which has negatives, which it kind of disqualifies it, but let's not even look at that. If this is my function, then this point better be on my function. Meaning when x is the first one, x, I better get this number for y. So if this function is really this graph, when x is 2, I should get 200. But when x is 2, I get 100 divided by 2, which is 50, not 200. This one's not right. Over here, 100 divided by x, but x is 1, is 100. It's not 200. So this is wrong. Over here, 100 divided by this 1 is 100, which is what they get. They're saying when you plug in 1, you get 100. So this one looks okay for now. And then this guy, when x is 1, they're saying that it's 50, and it's not. Okay? It's not 50. So this one's out. So the answer is C. What are the asymptotes of this function? You can tell by looking at the graph, you guys, but let me recopy the function down for you down here. Let's just do it the old school way, all right? How do we get a vertical asymptote? You guys, you get the vertical asymptote just by taking whatever is in the bottom, the denominator, which in this case is x, and you set it equal to 0. This is the vertical asymptote. Okay, that's it. Now, is it always just like that? Like write the bottom equals 0 and you're done? Sometimes you have to solve, but in this case you didn't. I'll definitely do one where you have to solve. But for now, that's it. Now for the horizontal asymptote, we use Bobo button. Bobo button eats DC. So that means that if my degree is bigger, so you check the degree. In this particular case, the degree of the top, remember, degree is the biggest exponent on an x in your equation. And in this particular one, there is no x, so my degree is 0 up here. And on the bottom, the biggest exponent on an x is a 1. So my degree is 0 on top, and my degree is 1 on the bottom. So the degree is bigger on the bottom. That means that the asymptote is y equals 0. So y equals 0 is the horizontal asymptote. Okay? That's it for this guy. You can't have a horizontal asymptote and an oblique asymptote. So we're actually done here with asymptotes. All right? You can only have one or the other, but not both. Explain what's happening on the graph near the asymptotes. What does it tell you? So near the y equals 0 asymptote is right here. Y equals 0, the horizontal asymptote is right here. And look, the fact that it's going to 0, that means this, remember x was the speed. That means that as my speed increases, the time decreases approaching 0. The faster you go, the faster that you'll finish the race, the less time it will take. All right? Faster speed means slower time approaching 0. Now, even if you're in a rocket ship, you can go hecka close to a time of 0, but there's no way that it actually takes 0 seconds to finish the race. It's got to take something. It might be so little, but it's got to be something. So that's why it's approaching 0. That's why it's an asymptote. All right. What does it mean near this asymptote, the vertical asymptote? The vertical asymptote of x equals 0 means that, remember that this is time. The y is time. That as my speed gets so slow that it's close to 0, then the time it's going to take me to finish the race is getting longer and longer and longer. All right? So that means slower speeds mean longer time. All right? And then to write the end behavior, you guys, it's always as x approaches negative infinity, f of x approaches, and as x approaches positive infinity, f of x approaches. And then you're responsible for this part is what you got to determine, what it approaches. You guys, a good thing about these rational functions, this whole unit so far, is that your equations, your graphs, and behavior is always approaching the horizontal or oblique asymptote. And remember, we just have one or the other. So in this case, we have a horizontal asymptote. It's approaching the horizontal asymptote. So what was the horizontal asymptote? It was 0. So what's it approaching? 0. That's it. Okay? All right. Now this negative end behavior is actually irrelevant for this context because we're only looking at the positives, because this is swimming. There's no negative time. There's no x going to negative infinity, just so you know. But for general functions, you do need to know both. Okay. So that covers that. Now let's go look at this stuff, okay? You guys, on these, again, I don't, instead of doing it all, this is all about end behavior. So remember that end behavior is dependent on the horizontal asymptote or the oblique. Actually, let's do it. Let's just do a couple, all right? Remember that our horizontal asymptotes, we learn about them from Bobo. Bobo button eats DC. Bobo says if the degree is bigger on bottom, then y equals 0 is the asymptote. Okay, so in all of these, look, just a number, that makes the degree of the top 0. And then they have definitely more than a degree 0 at the bottom. This one has degree 2 because there's a x here and an x here, that's 2. This one has a degree 1. But it really doesn't matter. The degree is bigger on bottom. Both of these have y equals 0 horizontal asymptotes, which then means that their end behavior is that they approach 0. I'm not going to rewrite it all, but exactly like this. As x goes to negative infinity, f of x goes to 0. As x goes to positive infinity, f of x goes to 0. These guys are both bigger on bottom. They have the same end behavior. This one is different. This one has a degree of 1 on top and a degree of 1 on the bottom. So that's the exponents are the same situation, okay? We're going to look at this one. I'm going to do this. I'm going to do everything with this. Sketch it, do it all, okay? So now over here and over here. Yeah, let's do that. Let's go do everything for this one. 5x over x to the first plus 2. You know what? I changed my mind. Sorry, you guys. I know it's a little all over the place. But I'm just going to do everything for you guys on a random problem like this one. So if you need help with horizontal asymptote, vertical asymptote, all that kind of stuff, sketching a graph and behavior, we're going to do it all for this. And then I hope that you can use that to do the rest. All right? Let's look at 3x over x plus 6. So 3x over x plus 6. Does it have a vertical asymptote? Well, the vertical asymptote is denominator bottom equal to 0. So x plus 6 equal to 0. Okay? And you can solve it by going minus 6 to get x alone. To get rid of the plus 6, you have to go minus 6. And you get x equals negative 6. That's the vertical asymptote. It's at x equals negative 6. So what does that mean? That means there's a vertical line at negative 6 that I'm not allowed to touch. Okay, I'm not allowed to touch this. Okay, let's go check out horizontal asymptotes. Horizontal asymptote, Bobo, button, eats, DC. Okay, here we go. What is the degree of the top? It's 1, because the exponent is 1. What's the degree of the bottom? Top is 1. Bottom's degree is also 1, because there's an x to the first power on the bottom. So we have this situation where the exponents are the same. When the exponents are the same, we find the asymptote by dividing coefficients. So what's the coefficient? It's the number in front of the term that gave you the degree, the x, basically the number in front of x. So in this case, the coefficient of the numerator is 3. The coefficient of the denominator, if there's no number there that you can see, it's a 1. So my horizontal asymptote is 3 divided by 1, which is 3. It's y equals 3. All right? vertical lines have an equation of x equals a number. Horizontal lines have an equation of y equals a number. And yeah, it is kind of the opposite a little bit of what you would expect, but that is what it is. So now that means that there is a horizontal line where y is 3. So y is 1, 2, 3. Right here, there's a horizontal line that I can't touch. All right. Now you guys, do you see how I made a big plus sign? And there are 4 corners now of this plus sign. These rational functions have this shape curve that's going to be in 2 of these spots, all right? But it'll never be on top of each other, because then you would fail the vertical line test. So basically either here and here, or here and here, or here and here, or here and here might have that shape in it. But we don't know where. We gotta check. It's not as obvious as you would think all the time, okay? So what I would do is I would check. And the way that I would check is I check the left side of my vertical asymptote, and I check the right side of my vertical asymptote. So how do I check? Pick something. Vertical asymptote's at -6. -6 right here. Pick something to the left of it. Like -7. Let's pick -7. What do I get when I plug into this equation a -7? Don't just go assume, you guys. Actually watch, do it. It's 3x divided by x plus 6. So all I did was wherever this had an x, I changed the x to a -7 in parentheses. If you want to use your calculator to get the answer here, put extra parentheses here around your whole denominator. You could say 3 parentheses, -7 close parentheses divided by, and then parentheses, -7, close the first parenthesis, plus 6, close the second parenthesis. And your calculator can do this for you, all right? I'm going to do it by hand because it's not so bad. -21 on top, and -7 plus 6 is a -1. So -21 divided by -1 is a +21. So what this means is that at -7 for x, y is +21. That's an ordered pair, which tells me that at -7 right here, I'm all the way up at +21, like way up here. Now, I don't actually care where I am, other than to know that I'm inside this square. So I draw this shape approaching these asymptotes in this square, not this square. That's it. That's good enough. That's good enough for a sketch, you guys. All right? So we found out that on the left side of our asymptote, we're on top. We're above the horizontal asymptote, not below it. So we're done with the left side. Now we check the right side. On the right side, I have all these numbers to choose from to plug in. You could pick whatever you want. I happen to really like 0. 0 is so easy to plug in a lot of the time. So on the right side, I'm going to plug in 0. But you could plug in whatever else you want. You could plug in -4 or -1, or I don't recommend it, but 10. So just pick something to the right of the vertical asymptote. It's 0, and then see what we get. 3 times 0 divided by 0 plus 6. Which if you type in exactly like this, the calculator will give you the right answer. But 3 times 0 is 0. Divided by 0 plus 6 is 6. And 0 divided by 6 is 0. Which means my point is actually at 0, 0 right here. Now, I kind of just, I don't necessarily care that it's there. What I care is what it tells me. That the second curve is in this portion, not that portion. So, since I know the point, I'll go through it. We just approach the asymptotes with that shape, just like rotate it around, like this. That's it. That's everything. I didn't do end behavior. I'll do it in just a second. But that's vertical asymptote, that's horizontal asymptote, and that's a sketch. It's also, let's do end behavior. As x approaches negative infinity, what does f of x approach? And as x approaches positive infinity, what does f of x approach? You guys, with these rational functions, if you have found the horizontal or oblique asymptote, you have found the end behavior already. It's just 3. Just put a 3 and a 3. Because if you look, the function as you go super far to the right is approaching this 3 line. And as it goes super far to the left, it's approaching that same 3 line. That's what the horizontal asymptote does. All right? Okay. All right. Let's do something else. Let's go and do something that has an oblique asymptote. So I'm actually going to flip back to these. These all have oblique asymptotes. Let's go look at how I know that. Remember when we check for horizontal asymptotes and we ask Bobo, Button, Eats DC, right? Bobo says that if the degree is bigger on the top, there is none, meaning no horizontal asymptote. None. But when there's no horizontal asymptote, maybe there's an oblique asymptote. Here's how we check. There is an oblique asymptote if, and only if, the degree of the top is exactly 1 bigger than degree of the bottom. So look at this one. The degree of the top is 2. The degree of the bottom is 1. The top is 1 bigger. This has an oblique asymptote. Same here. And same here. All 3 of these have oblique asymptotes. How do we find these oblique asymptotes? We divide. I recommend with the box. So let me show you. If you don't like the box, please don't judge it. Give it a chance. You can learn it now, and you can find the oblique asymptotes. And the good news is that if all you want is oblique asymptotes, so you're dividing using the box, you only need to do 2 steps. You don't have to do it all. Okay? So here we go, watch. What you do is, you make this box right here. And you put inside the first square the top first term, x squared. And then you put on the side this one, x plus 5. And then you just do 2 steps, remember, 2 steps. I'm going to erase this one because it's going to confuse us. The degree here was 1. Okay. Now you say x times whatever was here made x squared. What was here? Well, since x times x is x squared, that must have been an x. Then you say, well, if that's an x and that's a 5, I know I got to multiply these 2 to get this box. So this box is 5x. We are trucking along. That was 1 step. We are almost done because I told you only have to do 2 steps. Now you say, well, this is a 5x. But this equation right here, the one that's going inside these boxes, right? The x squared one in here, it has a 4x, not a 5x. I gotta fix it. Not fix it like erase this, but fix it like take 1 away so it becomes 4. So this is a 5x. Let's go minus 1x in this box so that these two combine together to make 4x like it's supposed to be. And now that I have a minus 1x here, x times whatever was up here multiplied to make the minus 1x. So up here must have been the minus 1. Now negative 1 times x is negative 1x. And that's it. You just did 2 steps, which means you found the oblique asymptote. What is it? It's this. Just put a y equals in front of it. Y equals x minus 1. All right? Just do that. Just y equals x minus 1. That's all you really need. Okay. That's the equation of the oblique asymptote. Let's do one more to be super solid, you guys. Here we go, watch. Degree of the top is 1 bigger than the bottom. That means no horizontal asymptote, yes oblique asymptote. So I make the box so that I can find the oblique asymptote. First guy goes right here, x squared. This guy goes right here, x plus 4. Then we do 2 steps. X times what makes x squared? X. So then x times 4 is what? It's 4x. Okay, well, it's 4x. However, I look up here and it was supposed to be negative 1x. See that minus x is a negative 1x. I didn't want a positive 4x. I wanted a negative 1x. So I have to put in here something that combines to make that. That's negative 5x. Now, if that is like, holy crap, where did that come from? All you must do is take the number that you want, which is negative 1, and then subtract the number that is in this box, 4. Negative 1 minus 4. Use your calculator if you must. It tells you negative 5. And so that's what goes here. And now if this is negative 5x and there's an x right here, then up here is a negative 5. And that's it. Y equals x minus 5 is the equation of the oblique asymptote. Okay? That's it. You did it. It's fantastic. Okay. Let's talk a little bit, you guys, about holes. Because we have covered horizontal asymptote, vertical asymptote. What we have not talked about is ooh, I'm so bad at drawing block S's. Holes, all right? Let's look at holes. How do we get one? The way we get one is if we have the same thing on, I should say factor with x, on numerator or on top and bottom. So watch. Things that have a hole. Y equals x plus 2 over x plus 2. Same thing on the top and the bottom. That thing has a hole. Look at this guy. Y equals x plus 3, x minus 2, x minus 2. That has a hole because there's an x minus 2 and an x minus 2. You see? Let's look at another one. Y equals x minus 3 over x minus 3, x plus 5. That has a hole. Okay? because there's the same thing on the top and the bottom. In each of these, when this cancels, these cancel each other out. We get a much simpler equation. Watch, over here, these guys cancel out. This is just 1, right? There's nothing left, it's just 1. Over here, these guys cancel out. This is just y equals x plus 3. And over here, these guys cancel out, and this is just y equals 1 over x plus 5. But, a big but, these all have a hole, and we can't just ignore it, all right? We cannot forget that we did once have this in our lives. These were in our lives at one point. We must remember them. This x plus 2 that was once here made it so that x was not allowed to be negative 2. Because negative 2 plus 2 would be 0. How do you figure that out? Take the x plus 2, set it equal to 0, and solve. Minus 2 minus 2, x is not allowed to be negative 2. In this one, it was x minus 2, so x minus 2 equals 0. 2. This one had a hole at x is 2, meaning we couldn't be 2. And on this guy, we had a hole at 3. So they do simplify to be much simpler functions, but with a hole. That's the hole. That's the hole. That's the hole. Okay? So let me real quick come over here to task D and show you. Write an equation that has a hole at x equals 4? Okay. Then I need a x minus 4 on the top and the bottom, with any other stuff that I want. But at least this has to be there. You can have more on the top or not. You could have more on the bottom or not. As long as these guys are here, you've got yourself a function that has a hole at 4. Number 2, I want a hole at 2 and a vertical asymptote at negative 5. Okay. So the hole is the thing that cancels. So the x minus 2 that gives us the 2 needs to cancel to be a hole. But that negative 5, x equals negative 5, needs to be an asymptote, meaning it needs to not cancel. Like that. All right? So now I'm going to go back to this part where I was talking about holes and show you guys graphically what the hole looks like. You guys, all it is you graph this function, this one, and then you just go to the location of the hole and you put a little circle there. Watch. Y equals 1, that's a horizontal line at 1. So it looks like this. At 1, there is a horizontal line like that. But there's a hole at negative 2. So go to negative 2 and put a hole in your graph. That's it. All right. That's what a hole looks like. Ooh, my kids are coming. All right. Let me try to just do this one, you guys, and then I'm going to have to wrap up this video. But please pay attention to this one. This one right here. Y equals 1x plus 3. Okay? This is a linear mx plus b equation. You start with the plus 3. Going to 1, 2, 3, and you make a point right there. That 3 is this 3 right here. You go to the y-axis, and you put a dot on the 3. And then that 1 in front of your x, that's your slope. Make it a fraction by putting it over 1. And then go up that many and over to the right that many from here. So go up 1, over to the right 1. Boom, boom. Like that. And now connect these. So this is this line, no hole, But we do have one at 2. So then you just go to 2, which is like up here, and just put an open circle. Okay? Okay, you guys, I gotta go. I do think that I covered everything that you need to know, everything we learned in this unit. Yeah, I did. I really, really did. I do want to show you just one last thing, okay? Let me show you one last thing. I want you to be so familiar that it's not that hard for you, that you know what a y equals, I don't know, something like 2x plus 3 looks like. I'm not going to even draw these grid lines. I just want you to have a general idea of what these graphs look like. So when you see just boom, 2x plus 3, all right, that's a line. It looks like that. General idea. I'm not drawing axes. I don't know exactly, okay? What if this was y equals 2x plus 3, but then it had like an x minus 1 and an x minus 1? What would this generally look like? Well, this would cancel, causing a hole. So it would look exactly like this, but with a hole somewhere. Okay? What other functions have we learned about this unit? We've learned about your straightforward rational function that has a, let's just say, x plus 3 over x minus 1. Okay? This guy has a vertical asymptote, and according to Bobo Button, check it out, it also has a horizontal asymptote. So a rational function that has a vertical asymptote and a horizontal asymptote in general looks like this. That shape. And I don't know why I drew the axes, because remember, we're being super general right now. I just want you to know that that's what that looks like. Okay? And if this same exact guy had a hole, if it was y equals x plus 3 over x minus 1, but then there was also an x minus 2 and an x minus 2, causing a hole because these cancel, it would look exactly like this. With a hole somewhere. Okay? And, did I kind of go over? Oh, I didn't go over one with an oblique. What if we had a y equals x plus 2, x minus 1 over x minus 3? Nothing cancels, no holes. But the degree of the top is 2, and the degree of the bottom is 1. So I have no horizontal asymptote. I do have a vertical asymptote. And I do, because the top is 1 bigger than the bottom, I do have an oblique. So what does this look like? This looks like this. Again, no axes. This looks like a vertical line with a slant asymptote. And then it either is going to look like that with these little squishy curves, or it could potentially look like this with these wide curves. But it doesn't look super balanced like the ones that have a horizontal asymptote. It's like this. All right? That's it, you guys. I just wanted you to be a little familiar with that and understand. Make sure you know all these different shapes of things that we have looked at. All right. If you followed along with everything I just taught you here, and you could do, then you should be able to do all the problems in this review. And you should be pretty good for your quiz. Good luck, guys.